is page 113, okay? We're going to work those odds, starting with number 1. Take a look at it. It says the sum of 38 and twice a number is 124. So we're adding, right? The sum of two things is 124. The question is, what are the two things being added together? Well, one of them is 38. What's the other one? Yep, good. So this is the sum of 38 and twice a number is 124.
Gentlemen, half into the office, please.
So, our first portion of this adventure, which you all have learned how to use it, but we've not done it this way, is if there are multiple things going on, like a multiplication, which we have to divide, and you don't recognize this, but this is a positive number, which we're going to subtract. If there are two things going on without parentheses or division bars, you have to perform the addition subtraction first. It doesn't matter that it doesn't say 2n plus 38. It's still an addition situation. Subtract your 38 from both sides, right? What do you get? 86? Good. Now we can perform any multiplication or division by dividing by 2, and you should have gotten 43. Now, that answers the question. Therefore, the number that we are discussing in this equation is 43. Not that you have to write it that way, but I want you to recognize that they're asking you specific questions. And we'll encounter that in 7 and 9. So, number 3. Four less than half of a number is 17. Find the number. They're not saying 4 minus half a number. They're saying 4 smaller than, 4 less than half a number. So there definitely is subtraction going on. The question is, what's the minuend and what's the subtrahend? What's being removed? Yep. 4 less than half a number. 4 less than half of a number. 4 smaller than that. It's almost like if you go to the store, or if you're making a goal for yourself. I hate to use this one, but it's an easy one for girls to imagine. Let's just say you wanted to lose weight. And you said to yourself, I want to be 2 sizes smaller. Whatever. So if you're starting out at a certain size, that's what's being subtracted. You're subtracting the 2 from where you're at. Okay, that's what's happening here. You're subtracting the 4 from what you have. 4 fewer than half a number. Okay, this mistake here, easy to make. Add 4, right? Plus 4. So that means 1/2 of a number is 21. Can't divide by a fraction. What do I do instead, folks? Yeah. So the 2 over 1 cancels the half, leaving me with n. And 21 times 2 looks like it's 42. So to answer the question were I asked to do so, which I was, the number is 42. Try number 5, and I'm going to actually work it here as well. Try number 5. I'm just not gonna say it loud, so you guys can't hear me. Did you guys come up with an answer? What'd you come up with? 27? Good, awesome. 4 more than 2/3 of a number is 22. Subtract 4, multiply by the reciprocal of 2/3 for the division. You're done. All right. 3 consecutive integers whose sum is 171. Let's review that whole process. So we've got, before I do the problem, I want to review what the 3 scenarios is. 3 consecutive integers. So if the first one is n, what's the next one? This is consecutive integers, not odd or even. +1. And what would the last one be? Yep. So this is 3 consecutive integers. How about 3 consecutive? And you could test this, by the way. Let's make n 1. What does this become then? And this becomes making it 3 consecutive integers, right? Let's do 3 consecutive odd. The first one starts the same, doesn't it? What's next? n plus 2. And last? And you could test that. But you must test it with an odd to start with. What would you like to use for that first number just to test ourselves? 3 plus 2 is? And 7? Good. How about 3 consecutive even? What do you think for 3 consecutive even? First one will be? Next one will be? And? Why is it that both of these can be the same and one indicates odd numbers and the other indicates even? Why? Why does that work? Kat, why do you think it works? Well, what did we start with here, an odd or an even? And if we start with odd and add 2 and then 4, it stays odd. What do you guys want to start with to test here, an odd number or an even number? Even. So 4, 6, and 8, for example. So this scenario, folks, the reason it works is because whatever you get as your n value, if n solves for odd, it stays odd by adding 2, 4, 6, however many you need, 2, 4, 6, ... If n is solved for an even, all of the same thing from above stays the same. It stays even by adding 246. That's why I know a lot of you, I've noticed, make a mistake as doing, make it 3 consecutive odd and you start with whatever and then n plus 1, n plus 3. But if you actually tested it, if you tested it with an odd number and added 1 to it, it becomes even. So adding 1 is always going to flip the value from odd to even or even to odd. So with that said, let's go ahead and head into number 7. 3 consecutive integers whose sum is 171. Number 7, find 3 consecutive integers whose sum is 171. Consecutive, that's going to be the first scenario that I just shared again. 3 consecutive integers. These are my integers whose sum is 171. Three consecutive integers that when added together, their sum is 171. Looks like when we collect our n's, we end up with 3n, and when we collect our constants, we end up with 3. You guys can solve from there, I'm sure. And when you answer the question, if you tell me the answer is 56, you're only partially correct. What are the 3 integers, Kat? Mm-hmm. Okay. Uh-huh. Last? There you go. So you're going to solve the equation and come up with this, but you have to utilize that to interpret your data and say, well, the first one's 56, the second one's 57, the final one must be 58. 2 more. 4 consecutive evens whose sum is 244. Here's a number, here's an even, here's an even, here's an even. This represents 4 consecutive odds or evens. Doesn't matter. You use it because whatever you solve for then keeps the trend, keeps odd, keeps even. 4 consecutive even or odd whose sum is 244. What we solve for, once you add 2, 4, and 6 to it, it'll stay odd or even. Looks like I got 4n plus 12, am I right? What do you think? You know you're on the right track when what you solved actually is even. Well, that's what we wanted. So we did come up with an even number for our first value. The first one's 58. What's the next one, guys? Keep going. 62 and 64. Good. Number 11. So, real world stuff. Bert's Burger Barn sold 495 burgers. The number sold with cheese was half the number sold without. What do we want to find? How many of each kind? And what are the two scenarios that we're dealing with in the land of burgers? Bacon, chili. One is with cheese and one is plain. Let's just call it plain. So they're analyzing how many cheeseburgers versus how many plain burgers were sold, but we do know one thing that'll help us. We know that cheese is half of plain. The number sold with cheese, according to the story, is half the number sold without. So how will I use that data, create a variable, to explain the number sold with cheese is half of what was sold without? What do you think? So P, good. You want to use P for plain? And what do you want to use for cheese? Wonderful. Great, now what? Yep, so cheeseburgers added to plain burgers equals how many? What does the book say? 495, yep. And cheeseburgers we represented this way. And plain burgers we're going to represent this way. Now we have an equation, and this is where some confusion tends to come because you have a coefficient that's a fraction. Combining these, you can either say it's 1.5 or keep it a fraction, which this is 2 halves, right? 1 is the same as 2 halves. Keep it a fraction, so the sum of the two coefficients is 3 halves p. Good? It's easier to solve it this way because you can just multiply by the reciprocal for the division of the coefficient. Reduce 495 by 3. And multiply it by 2. What do you get? Oh, actually, no, don't. Yeah, I solved for P, plain. Multiply it by 2. 330? Yep. That means plain burgers is 330 and cheeseburgers is 165. There is one other way of solving this. If cheeseburgers is half of plain, isn't plain double cheese? So what I mean by that is if cheeseburger is half of plain, then I could use C as a variable and solve it that way as well. Those two variables represent the same thing. For example, how old are you guys? 15? Okay. I'm 30. I was 30 14 years ago. I'm 30. So you are half my age, right? Based on that data. What am I based on you? Double your age. So all we're doing is, depending upon what we're referring to, we are using descriptive fractions or multiples to explain the other piece. Plain is more than cheese. Plain, cheese is half. Plain is more than cheese. Cheese is half. Both of these things state the same exact thing, are just worded slightly differently.